Jai Hind everyone. My name is Ankita Rani. I am working as an assistant professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. Today we discuss the topic software testing, and this topic comes under the subject software engineering, and the subject code is KCS 601. So, what is software testing? So, basically, testing is a process of testing the software product. So, testing strategy provides a framework or set of activities which are essential for the success of the project. They may include the planning of the project, designing of test cases, execution of the program with test cases, and interpretation and the outcome, and the finally collection and management of the software project. So, testing is the process of executing a program with the intent of finding the errors. So, if we find any error during the software development, we can test these error, find and remove these error through the process of the software testing. So, software testing will contribute to the high quality software product and maintenance cost, more accurate, and the reliability of any software product. So basically, software testing is an activity of software development process for finding or removing the error during the software development. So why should we test? Although software testing is itself an expensive activity, yet launching of software without testing may lead to costs potentially much higher than that of testing. So in the software life cycle, the earlier error are discovered and remove the lower is the cost of their removal. So in software testing, if we deliver the software product or if we launching the software product without the testing, so in case we have find any error, so the software can be expensive. But if we launching the software product, before launching any software product, if we test the software, then the cost of their removal is less as compared to the launching the product without done the software testing. So testing requires the developer to find error from their software. In every stage, we perform the testing like in designing, like in requirement analysis, like in coding. We analyze the test, we analyze our code, we analyze our design. So testing requires the developers to find the errors. So it is difficult for software developer to point out error from own creations. Many organizations have made the distinction between the developing and the testing phase by making the different people responsible for each phase, because in software development lifecycle we have different team, like in requirement analysis we have different team, for designing we have different team, for testing, for coding we have the different team. So for any type of error, different people can responsible for each phase. So why should we test? So we test the program responses uh, to every possible input. It means we should test for all valid and invalid input. All kind of inputs in the software program we can test, like all valid inputs and all invalid inputs, all are tested in our software testing. And it also execute all the possible path of the program. A program path can be traced through the code from the start of the program to program termination. To two paths differ if the program execute different statement in each and execute the same statement but in different order. So these are the some types of error, like error, mistake, bug, fault, and failure. Now we can discuss one by one what is error, what is mistake, what is bug, what is fault and failure. So people makes error. So like the software developer who are developing the software can make any error. A good synonym is mistake. We can say the error as a mistake, and this may be a syntax error or misunderstanding of a specification, and sometimes there are logical errors. So when developer make mistakes while coding, we call these mistake bugs. So when we do some coding, that time of errors that time of mistake are called as the bugs. So a fault is the representation of an error. So error can be represented through the fault, where representation is the mode of expression such as narrative text, DFD, ER diagram, and this is the mode of the expression. And defect is a good synonym for fault. For fault, we can fault is also called as an defect. And a failure occur when a fault execute. If the fault execute in our software testing, failure may occur. So a particular fault may cause different failure, which is depending upon the how to how the software product can be tested. So there are some test cases and test suite. So the test cases is a triplet of ISO, where I stands for the data input and S stands for the system and O stands for the expected output of the system. So the test cases is make by using these three triplet ISO. Next is test suite. What is test suite? This is the set of all the test cases. The test cases which is designed with the help of the ISO, like input, system, and output. And the test suite is a set of all the test cases with which a given software product is to be tested. So the set of test cases is called as a test suite. So this is the test case template. Like in this, we have to write the test case ID, and we have in two sections. In that, we have section 1 and we have section 2. In section 1, we have before execution, and in section 2, we write all the things after the execution. First is purpose. What purpose? We can write the test case. Next is precondition, if any. If any condition before testing of a software product, we can write this condition here. Next is inputs. What are the inputs we have taken for testing any software product? Next is expected output. What output are to be expected? Next is post conditions. What are the conditions are arrive after testing the software product? Next is the written by, and next is date. So these are all are the things before the execution in section 1, but after the execution in section 2, we have execution history, how our software product are executed and what the result will came, and if fail, any possible reasons, what are the reasons the software testing can fail, and any other observations and any suggestions. If you want to give some suggestions, and run by and date. So this is the test case template. By using this template, we can create any test case, and the set of test cases is called as the test suite. So the test data input and test cases. So test data inputs which have been devised to test the system, and test cases inputs to test the system and the predicted outputs from these inputs if the system operates according to the specifications. So we have the concept of the verification and validation in the testing, because testing is equal to verification plus validation. Testing is a combination of verification and the validation. In verification, verification is the process of evaluating a system or component to determine whether the products of a given development phase satisfy the conditions imposed at the start of the phase. But in validation, validation is the process of evaluating a system or component during or at the end of the development process. So validation can be done at the end of the development process, but verification can be done at the start of the phase. So in starting, we can done verification, but at the ending, we can done validation, whether it satisfies the customer requirement or not. So these are the level of testing. Basically, there are the three levels. First is the unit testing. Second is integration testing. Third is system testing. This is the diagram of unit testing. In unit testing, all the modules can work as a single unit. This is the single unit, and these all are the modules. But in integration testing, so this is the in this Some modules are connected to each other, like these modules are connected to each other, these modules are connected to each other. But in system testing, whole system can integrate and all the modules are connected to each other in the system testing, because it creates the whole system. So first is unit testing. There are the number of reasons in support of unit testing, then testing the entire product. So the size of the single module is small enough that we can locate an error fairly easily. So basically unit testing is easy because the size of the module is small, because we can test one module at a time. So the module is small enough that we can attempt to test it in some demonstrably in-depth fashion, and it also create confusing interaction of multiple errors in widely different part of the software are eliminated. So those modules which can create confusions are eliminated in the unit testing. So there are some problem which is associated with testing a module in isolation. So how the problem can be solved by using the uh, construct the driver routine, by construct the driver routine, or to construct the simple stub. So there are the two things, the driver and the stub, and they both are called as a dummy. So stubs serve to replace modules that are subordinate to the module to be tested, and it is also as a subprogram or a dummy program to test the modules. So this is the diagram of showing how the test a program unit, how the module can be tested. First of all, we have a driver. Driver is our dummy, and in driver we have to give user input. This is the user input and this is the user output. Both input and output is taken by the driver, and after that driver can test the module with the help of the parameters like parameter out. And after testing the modules, uh, these modules are tested with the help of the stubs. Like these three modules are tested with the help of the stub, like stub 1, 2, 3. So driver and stub are both the module, are the dummy through which we can test the modules. After testing, they can give the parameter back to the driver and they can generate the output. So this is the process of how to test a program unit. So stubs are dummy modules that are always distinguished as called programs, or you can say that is handled in integration testing. Integration testing is also called as top-down approach. So basically, stubs are handled in the top-down approach and it used when subprograms are under construction. So stubs are considered as the dummy modules that always simulate the low-level modules. So stubs are works in the low-level modules and they also consider as a dummy modules. Next is driver. Driver are also considered as a form of the dummy modules. We can also say that driver is also a dummy modules which are always distinguished as the calling programs, and that is handled in the bottom-up approach. Stub are handled in the top-down approach, but drivers are handled in the bottom-up integration testing, bottom-up approach in the integration testing, and it is only used when main program are under construction. So driver are considered as the modules that always simulate the high-level modules. Stub are work simulate under the low-level modules, but driver are simulate under the high-level modules. Next is integration testing. After the unit testing, second level of testing is the integration testing. The purpose of unit testing is to determine that each independent module is correctly implemented. This gives little chance to determine that the interface between module is also correct, and for this reason integration testing must be performed. So focus on interaction of modules as a subsystem. So in integration testing, we can integrate some modules. So unit tested modules combine to form the subsystems. So in integration testing, we can combine the unit tested modules to form the subsystems and test cases to exercise the interaction between the modules in different ways. So there are the two approaches like top-down testing and bottom-up testing in the integration testing. First, we discuss the top-down testing. In top-down testing, we perform like in this manner. We have level 1 like testing sequence. So it start with the main routine. Our main routine is this, and we have some one or two subordinate. This is the one or two subordinate. After the top level skeleton has been tested, the immediately subroutine of the skeleton are combined and with it and it tested. So top-down integration testing approach require the use of program stuff to simulate the effect of lower level routines that are called by the routines under tested. So these are the levels, level 1, level 2 and level 3 stuffs. So this is the top-down testing approach. Next is bottom-up testing. In bottom-up testing, each subsystem is tested separately and then the full system is tested like bottom-up. Like we have to, this is tested separately. After that, primary purpose of testing each subsystem is to test the interface among various modules making up the subsystem. So both control and data interfaces are tested, integrate individual components in levels until the complete system is created. So after testing, they integrate all the levels. So at this point, after that, they integrate all the levels. This they integrate. So this is the bottom-up testing in the integration testing. After the third level of testing is the system testing. System tests are designed to validate a fully developed system to assure that it meets its requirement. There are essentially three main kind of testing: alpha testing, beta testing, and acceptance testing. So alpha testing refer to those system testing carried out by the test team within the developing organization. Like in the organization, we can test over the software product. In beta testing, beta testing is the system testing performed by the selected group of friendly customers. Like software developer have some group or have some friend circle, then these group can test the software. After that, third is acceptance testing. In acceptance testing is performed by the customer to determine whether he should according to the customer requirement or not. So acceptance testing is done by the customers to check the customer's requirement. So these are the some attributes of the software to be tested during the system testing. Like we can check the usability of the software, we can check the security of the software, whether it is safe, secure or not. Next is compatibility, will the product work. Next is dependability. After that, documented. So these are the attributes which are tested, attributes of the software to be tested. Next is the approaches of testing. There are basically two approaches of testing: black box testing and white box testing. In black box testing, also called as functional testing or behavioral testing. In black box testing approach, test cases are designed using only the functional specification of the software, means without any knowledge of the internal structure of the software. So in black box testing, we do not have the internal knowledge without any internal structure knowledge. And the tester only know the input that can be given to the system and what output the system should give. So it means in black box, we have only the customer can know the input and the output, and they do not have the internal structure and internal structure of the software. So this is the diagram of the black box testing. In this, we can give the input, and after that the system under test, and they can generate the output test data. So test cases are designed from an examination of an input or output values only, and no knowledge of design or code is required, because in black box testing we know only the input and the output. But in white box testing is also called as structural testing. In this, we have to examine the internal structure of the program. It permits us to examine the internal structure of the program. So this is the main difference between the black box and the white box testing, is that in black box we don't have the internal structure of the program, but in white box we have the internal structure of the program. So in the white box testing approach, designing test cases require thorough knowledge about the internal structure of the software. So therefore the white box testing is called as the structural testing, because in this we have the structural knowledge of the program. So there are the various criteria of the white box testing, like path testing, flow graph, DD graph, cyclomatic complexity, graph matrices, mutation testing. These are the some criteria of the structural testing. So these are the some other types of testing, other 9 types of testing, and that are called as the performance test. First is stress testing. So in stress testing are the black box tests, which are designed to impose a range of abnormal and even illegal input conditions so as to stress the capabilities of the software. So in stress testing, we have abnormal inputs and even illegal inputs. Next is volume testing. In volume testing, it is especially important to check whether the data structure have been designed to successfully extraordinary situations or not. Like we check the data structures like array, queues, stack. For example, a compiler might be tested to check whether the symbol table overflows with a very large program is compiled. Next is configuration testing. In configuration testing, this is used to analyze the system behavior in various hardware and software configuration. Basically, in this, we check the hardware and software configuration of the software. So sometimes systems are built in variable configurations for different users. For example, we might define a minimal system to serve a single user and other extension configuration to serve additional users. Next is compatibility testing. So in compatibility testing, this type of testing is required when the system interface with other type of system. Means we check the compatibility between different systems. So compatibility aims to check whether the interface functions perform as required. For example, system needs to communicate with a large database, but a large database system to retrieve the information. So we have to done the compatibility testing, whether it is required to test the speed and accuracy of the data or not. Next is regression testing. And regression testing, this type of testing is required when the system being tested is an upgradation of an already existing system to fix some bugs or enhance functionality, performance, etc. So regression testing is the practice of running an old test suite after each change to the system or after each bug fix to ensure that no new bug has been introduced due to the change or the bug fix. So basically, regression testing can be done in the old test suite after each change to the system. So if we done any upgradation in the system, after every upgradation, we can done the regression testing. However, if only a few statements are changed, then the entire test suite need not be run. Only the test case that tests the function that are likely to be affected by the change need to be run. So this is the regression testing which can be done after every change. After that, we have recovery testing. So in recovery testing tests the response of the system to the presence of fault or loss of power or device or services, data, etc. So in recovery testing, we recover the data through the we recover the data from the failure, from the fault, from the loss of power, from the services, from the data, and is checked if the system recovers satisfactorily or not. For example, the printer can be disconnected to check if the system hangs, or the power may be shut down to check the extent of the uh, data loss and the corruption. So in recovery testing, we can, next is maintenance testing. After maintenance testing, in maintenance testing, this testing address the diagnostic program and other procedures that are required to be developed to help maintenance of the system. Next is documentation testing. In documentation testing, it is checked that the required user manual, maintenance manual, and technical manuals exist and are consistent. Basically, in this, we check the user's manual of the software. Next is usability testing. In usability testing, it concerns about checking the user interfaces to see if it meet all the requirement concerning the user interface or not. Basically, it check the whether it satisfies the customer requirement or not. So these are the 9 performance testing. Thank you.